Right, camera action.
Okay. Today we will continue review the left trigonometry. It is very important. It is very important. Sine, cosine, tangent. Okay. It's not just important for linear algebra. Is the ratio. We are talking about a ratio. The ratio is important. Um, Depending on how we go today, if we have time, we will move on to the norm again, the vector length, and so on so, dot product. Okay. Where is the sign? Just let's say 30-degree angle. Which line? This is a unit circle. This is a unit circle. This is a unit circle. Okay. The radius is 1. The reason why it's called a unit is the radius is 1. Okay. My hand drawing not too good, but treat it like a circle. And if here has an angle, let's say whatever is the angle, okay? So can you tell me where is the sign? If this is a theta, can you tell me where is the sine theta? Where? I want to see the visuals. I want to see the visual. You draw a vertical line, okay, from here. Imagine we are inside a dome, watching a movie. And the movie screen, we hang a movie screen to the floor. Then that movie screen, the length, that is the sine theta. Okay? If you know this, then you will understand when it's y sine 0 is 0. Sine 0 is 0. Sine 0 is 0. You will understand why sine 0 is 0. Because now the movie screen is completely on the floor. Okay? When this angle becomes smaller, the movie screen is completely the 0. Okay? And you will understand why sine 90 degree. Here I'm saying the degree, okay? What's sine 90 degree? What's sine 90 degree? Is 1, because now the movie is hanging from the topic to here, okay? Right on above my head, hanging over there. Okay, is this part. This is a 1, which is also the maximum of a sine function. The sine function. So you will understand when the angle gets lifting up, the sine is gradually going up. Okay? And this is a 1. And in sine curve is when this is 0 degree, it's 0. When I finish it, I finish it. Okay. So when it's a 90 degree, when it's a 90 degree, reached to the is a 1. Okay. When the angle from 0 to 90, sine gets larger and larger. But it's not linearly. It's not linearly. Okay? It's not a straight line. It's not a straight line. It's a curve. Curve. So this movie string gets larger and larger. Now I set 2 fingers pointing at the same moon. Okay. Sometimes we are talking about the angle. Most of the time we are talking about the length of the arc. We are talking about here. We are talking about the unit circle, only on unit circle. This arc. Okay. The whole circle is 2 pi. The whole circumference is 2 pi. Okay? You can calculate it because it's 2 pi r. The circumference is 2 pi r. R is 1. We are always taking the advantage of this r is 1. So the circumference is 2 pi. Okay? And the half is a pi. Okay? From here to here, half is a pi. Right? And a quarter from here to here, is a half pi. Is a half pi. So most of time, 99% of time, instead of saying this is 1, we say this. We say sine is 1. We are saying this. This is the length. Length is much more common because it's just a number. The angle, so in 99% of the time when we are just using the length. So most of time, instead of label 90 degree, we label it pi over 2. Half pi. Okay? Half pi. So when we get here, let's say 90 degree, okay, plus 60 degree, so it's 150 degree. It's 150 degree. It's 150 degree from here to here. By the way, even though we have the class once a week, but even though that I generally do not give you homework, we try to do the questions in the class. You should browse. You should browse your notes during the week. Okay? Just browse it. We too long. We okay 1 week, or we are too long. Okay. Otherwise, every time you forget most of the previous week. Okay. And this is a 150 degree. because here is a 60 degree, okay? 60 degree plus the 90 degree. So for sine 150 degree, sine 150 degree, what's that? Sine 150 degree. Oh, by the way, can you tell me first, what's this one? Sine 30 degree. What's the result? Sine 30 degree. What's the result? Exactly. And for some just magic, when this is a 30 degree, this is a right triangle. This is a right triangle. The 30 degrees, the facing this side is a half of a hypotenuse. Hypotenuse. Okay? Hypotenuse is a 1. It's a 1 unit circle. So this is a half. Okay? This is a half. And what's the length for 30 degree? Huh? Yes. This is a pi. Okay? This is a pi. Basically, we chop to 6 parts. We chop to 6 parts. So it's a 1/6 of this. So it's a sine pi over 6. Okay? Sine pi over 6 is a half. And let's say half is here. Okay? And all these are hand drawing. So here is a pi over 6. Here is a pi over 6. Even if the hand drawing so this is a half pi. So this is 1/3 of this, right? This is one third of this. So 1/3 half pi is the pi over 6. Is over here. Following? Following? Pi over 6. Now here is my question. What's this one? Sine 150 degree. What's the result? What's the result of this angle? Sine. The movie, where is the movie hanging? Where is the movie hanging? It's over on my back, right? Is that above the floor or is it on the ground? Is it above the floor or yeah, it's above. Because it's above, it's a positive. It's a positive. Okay? And this result, this length and this length are equal. Because here, for this part, is a 30 degree. 150, right? Just short of 30 degrees, then it's a flat. 180 degrees. So this triangle, this right triangle, and this right triangle, what's the word? Anyway, are the same, okay? This right triangle and this right triangle are the same. So these and these are same. Following? So this and this is equal. Is equal. Is above, even though it's on my back. but is above the ground. Is a positive. Make notes if you haven't done it. It will be in your final exam. And you tell me what's this? And you tell me uh, I didn't draw it well, but if this is sine 210, sine 210 degree. What's the result? Sine 210 degree.
minus 1/2.
What's the sign? Is that positive or is it negative? Very important. Huh?
Negative.
Right, because it's get to the underground. Yes, gets to the underground. And the length, this length is actually the same as this length. Okay. Okay. And you tell me to express it in pi. To express it in pi. What's the? You tell me. Okay, you said it's minus 1/2. Yeah. And what is a pi? This is a pi. When you come to here, is a pi, okay? And you get more.
4 pi by 3.
4 pi by 3. Good, very good. This length plus the pi, and this length is the same. Oh, not? No, you got it wrong. Come on. You write it on your notebook. You write it on your notebook. What's here? What's the length here? What's this part? What's this part?
Oh, 7 pi by 6. 7 pi by 6. 7 pi by 6.
Pi over 6.
Yeah.
Because this finishes here.
7 pi by 6.
And I'm asking these 210. So it's pi plus this part. So it's a 7 by 6.
10 और 7 में कोई फर्क नहीं दिख रहा। एक ये 10 तो तुम्हें क्या
280 degrees. What's the result? What's the result?
0.
It's keep turning. It's on the back. Keep turning, and flat. Okay. The movie screen. This is the movie screen. It's on the floor. It's on the floor. It's 0. And what's the pi? So what's the pi? Okay. Okay. So where is here? Where is here? Pi. Okay. 180 degrees. Right. Pi is over here. So you can see in this area, when the angle gets larger and larger, the sine value is go downhill, is growing smaller, but it's not going straight line. You guys on YouTube. It's not going straight line. Okay? It's going by curve. It's going a curve. And the two sides is symmetric. The two sides is symmetric. And here you can tell if the two angles are like symmetric, then they are equal. Okay? Like this one and this one. So their sine values are same. Okay? If it's a 45 degree, okay? You tell me if it's a 45 degree. Should I draw it? Okay, I draw it. 45 degree. Okay? Where is the sine value? Where? Where is the movie screen? Where is the movie screen? Okay. First of all, this angle is larger than this angle. 45 degrees is larger than 30 degrees. This one, the sine 45 is larger than sine 30. This is important, okay? This is larger. Finally get to the maximum. When you get even larger, then it becomes smaller. When you get even larger, it becomes smaller. More larger, smaller, more larger, smaller, more larger, small, more larger, small, more larger, small. Eventually it becomes 0. And the more larger become negative. Okay? More larger become negative, more negative, more negative. When becomes 270 degrees. When becomes 270 degrees, it becomes -1, which is here. Which is here. So this is okay. If draw it here is -1. What's the angle here? Okay, two fingers points is 270 degrees. Okay, is you're turning all the way to here. Okay, turning all the way to here. And another using pi is what's the pi? Huh? 1 pi and half pi. Okay, 1 pi, half pi. So this becomes the lowest point. Lowest point. When keep turning, is still negative. Is still negative, but is going up. Is still about below 0, but is going up. The value is going up until we turn into the one circle. Is 360 degree. Okay, 360 degree, 2 pi. Yes. Okay, back to here. What's the value? Can you tell me what's the exact value? Can you tell me exact value? Sine 45 degree. And what's the pi? What is the pi? And what's the value? Pi by 4 is pi by 4. Okay, pi by 4 is pi by 4. This is a pi. So the 4 parts. Okay. This is a half pi. This is a half pi. Middle is a pi by 4. And what's the value? What's the value? Pythagorean theorem. What's the value? This is a 1. And the both sides are equal. Both sides are equal. So what's the value? What's the value? Is okay, both sides are same. I'll make it more clear. The square is a what? Is a 2 over 4. The square, which is 1 over 2. Okay? This square plus this square, half plus half equal to 1. This 1 square is 1. Pythagorean theorem. For 30 degree, very good. 30 degree, you're very good. 45 degree is also a special degree. The value, you need to memorize it. Write it on your notebook. The value, you need to memorize it. That's a joke. The people, they criticize math teachers, saying all the exams always using this angle, 30 degree, 60 degree, 45 degree. They don't test. Math teacher won't ask you what is the 31 degree sine value. They won't ask you what is the 28 degrees sine value. They always ask, because these are typical, and these answers are typical. So they never ask you what is 50 degree, sine 50. You can punch on your calculator. But in the math exams, they want to ask you what is 40 degree, sine 40. They always ask you 30. If they don't ask you 30 degrees, they ask you 45 degrees. If it's not 45 degrees, then ask you 60 degrees. Then 90 degrees, 100 degrees. These are typical. Is on your textbook. Is printed. On page 25. Page 25. Where's your book, man? Where's your book? Page 25. Oh, cosine. Sorry. Bottom is a cosine. You can add one row there. You can add one row. Sine. Add one row below to the cosine. I will come to the cosine after I finish this T. Cosine is in analogous with the sine. Is also this inside the dome story. Please make a note on this. This is a very good way to learn trigonometry, sine, cosine, tan. Instead of like the book, I tell you, remember this is 1. Remember this is 0. Remember that this is. I put a story for you to help you, understand it. Okay. And more important, you should know between 0 to 180 degrees is a positive. Okay? When it's larger than 180 degrees, it's a negative. Very, very important. After you add a cosine, then you will be confused. If you do not have this story in your mind, it will be slightly different story. So it's very important, when some angle like that, then they are equal. Okay, I forgot this. So if 90 degree plus 45 is 135 degree. It's 135 degree. This is 135 degree, okay? Let me. What is 135 degree? Can you tell me? Equal to which line? 135 degree. 135 degree is 90 degree plus 45 degree. 90 degree plus 45 degree is this and this are same value, okay? 45 degree and 45 degree and that is the same value. these lengths are exactly same. Both are positive. Both are positive. So sine 135 degree is also equal to that. Is also equal to that. And can you tell me what's the pi? What is the pi? Can you tell me what is the pi? From here to here, from here to here, how long the arc? How long is the arc? To here is a half pi. Here,
week5
is a 3/4 pi. The whole thing is a 1 pi. The whole thing is a 1 pi. I'm asking from here to here is a 3/4. Is a 3/4. Okay. So this is very important. 89 degree, 89 degree, and 91 degree, the sine value are equal. Following? 89 degree here. Let me exaggerate it. This is 89 degree. Okay? The sine value is here. 91 degree, 91 degree, okay? The sine value is here. Here and here are equal. 89 degree, 91 degree. I'm exaggerating the one, okay? 89 should be very close, but let's say it's here, okay? 89 degree is here. It's very large, almost 1, but it's less than 1. It's less than 1. It's from here to here, okay? 91 degree is from here to here. This and this are equal. They are both positive. They are both positive. Very important, okay? Let's say 170 degree. 170 degree here. So it's a 10. And 190 degrees here. Their value are the same, is opposite. One is positive. 170 degrees is here, okay? 190 degrees, 10 degrees more than 180 is below, is underground, is underground, is a negative, is a negative. If you have this story, then you know this, okay? Okay, we stop here. Okay. Now we go cosine. Cosine. Um, Cosine is, I will use the same here. So when an angle, let's say this angle 30 degree, or let's say more general, theta. So where is a cosine theta? Where is a cosine theta? Where is a cosine theta? Where cosine theta is, you need these, the two of brothers go hand by hand, okay? Go hand by hand. Never forget the movie screen, okay? And the cosine is the distance from the movie screen to your place. Is from the movie screen to your place, which for this angle, let's say for this angle, it is this part. It is this part. Okay? It is this part. You make a vertical line. You make a vertical line, and that dot to your distance. That dot to your distance. That is a cosine.
Cosine.
Yeah. Now, what is a cosine 0? You tell me what is a cosine 0? 0 degree or just a cosine 0?
1. Yes, 1.
Right. Is the movie is at the furthest dot, okay? This is 0. It's now you can, but tomorrow you will be a little confused. This is 1 because is the movie screen is at the furthest point, okay? It's 1. This is 1, okay? This is 1. Now, for the cosine 45 degree, for the cosine 45 degree, which is pi over 4. What's that? Cosine 45 degree. Cosine 45 degree.
1 over 2.
Is which part? I'm talking about this angle now. I'm talking about this angle. Is which part? Is this part, okay? Okay, because this you make a dot to the floor. You make to the floor. And it's always, for the cosine, we are always talking about the distance on the floor. Okay? For the sine, we are talking about the movie screen height. We are talking about movie screen height inside the dome. For cosine, we are talking about the distance on the floor. For 45 degree, this part are equal. Is still here. Okay? So this is a sine 45 degree. This is a cosine 45 degree. The value accidentally are the same. Okay, I use this blue one. And that's a general rule I should put out here. It's always true, no matter which angle, what's the theta value? Cosine square and, sine square and cosine square theta is always 1. This is always true. This is always true. And then here you can verify. When it's 0, okay, so this is 0, and this is 1. Okay, so this adds up to 1. And for 45 degree, is this here. This, and this is 1. This is a very important. Okay. Actually, for drawing, is this is a sine curve. Cosine curve is this. So in the beginning is 1 already. Because when the angle is 0, there is a furthest. Okay? When you move the screen, gradually moving, okay? Okay? So it's getting closer and closer. And it's positive because it's in front of me. The distance, very important, okay? Later, very soon become negative. It's a positive, okay? So when it's 90 degree, when it's 90 degree, the distance to me, what's the distance to me? 90 degree. 90 degree, what's the distance to me? Is at 90 degrees, the movie screen is right, me and movie screen. The distance is 0. Okay. The distance is 0. So F is here, the blue one. Getting smaller and smaller and is 0. It's like shifted. This sign is pushed a little bit, shifted inside. So cosine. You can tell sine and cosine is waving up and down between positive 1 and the negative 1. Never get larger than 1. Never gets below the negative 1. This is the two hand-by-hand brothers. Okay. Now, if this, what's this angle? 90 degree plus 45, 135 degree. 135 degree. What is the cosine value? What is the cosine value here? Yeah, it's a negative. Now, when it's over, the distance to me is from back to me. Okay, it's a negative. It's a very important. Then what's the value? What's the here? This and this are the same. Okay, it's just become negative. This is a 45 degree. Okay, so cosine 135 degrees. This one is a negative. This value is a negative. This value. Yeah. Yes. Cosine 135 degrees. Maybe I should write it here. 135 degree is a negative. I rewrite both better. So this is a positive square root 2 over 2. Here is a negative square root 2 over 2. Okay. Now you should know when the two angles are symmetric, we open it up around here. If it's the same, one is 45, another is 135. Both is a 45 distance to the vertical, okay? The cosine value is the opposite side. Here is a positive, here is a negative. The number of the absolute value are the same, but here is a positive and here is a negative. Are you following? Yeah. Okay, now you tell me 180 degree. What's the cosine 180 degree? What's the distance? What's the distance from the on the floor to me? 180 degree. Well, it's over there. What's the distance from there to here? -1. Yeah. The 180 degrees. The movie is over here. Okay. The height, the screen height is 0. The screen height is 0. Sine 180 degrees is not on the board. It's over here, okay? Sine 180 degrees is 0, but for the cosine is a -1. For the cosine is a -1. Are you following?
Yeah.
From over there to my foot, Okay. Now, if I so let me use this. So for the 210 degree, what's the sine 210 degree? What's the sine? It's here, right? Negative is a negative, right? -1/2. This and this are the same. This is here is a 30 degree. Here is a 30 degree. But we already have 180 and a 30 degrees. So it's a 210. So this is a -1/2. And here, cosine, I didn't ask you for the cosine 30 degree. Cosine 30 degree, what's the cosine 30 degree? Is where? Cosine 30 degree is where? Is where? Is here. Okay? Cosine 30 degree. Okay? From there to my foot.
It's the same value.
What's the value?
1/2.
No. This is 1/2. This is 1/2. This is not 1/2. It's if you really need, okay, 30 degree, okay. Oops, this too bad drawing. This is a 30 degree. And here is what? 60 degree, okay? 30, 60, 90. So it's totally is 180 degree. If this is a 1, then here is 1. Is 1/2, okay? And by Pythagorean, you can check. It's root 3 over 2. Okay? Root 3 over 2. This square becomes 3/4. This square becomes 1/4. Adds up is 1. So cosine 30 degree is this value. Cosine 30 degree is this value. Is here. Okay?
Yeah.
And you can check the two, these still hold. These still hold. Now I'm asking cosine 210. Cosine 210. Okay, I'm asking first cosine 150. Cosine 150. What is the cosine 150? Where is the 150 degree? Is this one? What is the cosine 150 degree? Where? Which line? For this one, from here to here. What is the cosine 150? Is it from the movie screen to my foot? Okay? This part. What's the value? Is that a positive or is it negative, first of all? Huh? It's on my back. It's negative. We are talking about, when we are talking about sine, it's a movie screen height, okay? It's above floor is positive, under floor is negative. For cosine is the distance to my foot, okay? So it's on the back, so it's a negative. So, it's a negative, but is this part and this part are the same.
-1.
It's not -1. It's a okay. Minus square root. Is the value are the same, but it's opposite sign. This is why for the cosine, if the two angles are symmetric to the vertical line, their value, absolute value are the same. Absolute value are the same. But one is a positive and one is a negative. Are you following? Are you following? Cosine is the distance on the floor. Is the distance on the floor. 90 degree, which is very important. Cosine 90 degree is the distance to me is 0. The sine 90 degree is what? Sine 90 degree is 1. The movie screen is the tallest. The cosine is the 0. Cosine is 0 because the cosine is the distance to my foot. Okay. Now, if this is 270 degree, can you tell me what is the cosine 270 degree? They're putting the movie screen in the basement. But I do not care is above ground or is below. I care the movie screen distance to my foot. the movie screen is a zero. Is a zero. Is here. 270 degrees is zero. Now, if I is putting over here, if the angle is that positive or is it negative cosine?
Should be positive.
If it's a 300 degree, 300 degree,
Positive.
300 degree. If it's a 300 degree here,
Yeah.
270 degree is over here. 30 degree more is a 300 degree. The cosine 300 degree is a positive or is a negative?
Positive.
Yes. It's underground. It's underground. But the movie screen distance to me is in front of me. Is here. Is in front of me. Very important. Cosine 300 degrees is this part. Okay? Is this part. Is in front of me, even though it is in the basement. Even though it's in the basement. Okay? Here, even though it's above. Even though it's above.
Behind of you.
Yeah, behind of me. So it's a negative. So for cosine, in here or here are positive. Okay? Is here or here is a positive. On the back, here or even there are negative for cosine. Okay? Is a cosine even there, all are negative. This is a positive. This is also positive. Because the movie screen to me is in front of me. For sine, this is a positive. This is also positive. It's on my back, but it's above ground. Following?
Yes. Yeah.
Here, like that. For sine is a negative. Because the movie screen is below the floor. Okay? And here is also negative. Movie screen. This is the movie screen. Okay? It's confusing.
Yes.
But if you remember this unit circle story, then you will be will remember. Okay? Are you following?
Yes. Okay.
So for the cosine, in the beginning is already 1. It is starting from a value already. At 0 degree is the distance to me is the maximum. When turning, so the distance to my foot becomes smaller and smaller. When it's vertical, it becomes 0 for cosine. At the same time, sine becomes 1. Sine becomes 1. And keep turning, and the cosine go below 0, go below to 0. Sine is getting smaller, but it is still positive. It's still positive, okay? And this is smaller and smaller. And at 180 degree, sine is 0, because the movie screen is on the floor, flat. But the distance to me is a -1, which is at this point. Okay, now get into the third, let's call it the first quarter, second quarter, third quarter, fourth quarter. In the third quarter, from 180 degree to 270 degree, both are negative. Cosine is a negative because a sine is a negative because it's cosine is also negative in this quarter. For the cosine is going up, but still below 0. Is still below 0. Okay, so gradually we're moving toward 0 for the cosine. When your angle is turning, then it's moving from -1, moving when your angle is 270, it hit here, it's 0. So it's from 180 degree, heading towards 0 at 270, moving to 0. And if you keep turning, and that dot, this distance, is getting further and further. So eventually it becomes a 1. This is a cosine story. Okay, and this is my review of trigonometry, and I hope you follow me well. Okay, and if you use you can ask me if you are not clear, or ask other classmates. We take a break, okay? Okay, stop. Yeah. I found it, this is the text. You can, is already recording? Okay. And now we're going to moving on to the norm and the dot product. The two are related. A vector, okay? Let's say a vector A, a vector B. Okay? Could be any vector. Could be a vector this, and a vector that in the 3-dimensional. Could be the 2-dimension, okay? Is on the board. To the 3-dimension. Okay? And so when this dot product that let's turn to the page 18. Page 18 and 18. The dot product. The definition. You guys should bring the textbook, okay? The formula is that one formula is on the board. Okay, so is let's say he's using U and V, okay. Okay, I follow the both. U, vector U, and the vector V. And if the vector U is U1, U2, and UN, they have to be the same dimension. This has 1, 2, 3, n, so means this vector is in n dimension. Okay, and V and is V1, V2, Vn. Okay. And if U dot V, then is first of all, the result is not a vector. The result is just a number. The result is just a number. Is U1, V1, U2, V2. I think I said something wrong last time. UN, VN, because okay. So for vector, for example, a vector 1, 2, dot, dot. Okay, 3, 4. I think I said something wrong. Because I never do this. I used to do other things. So what's the result? 1 times 3. 3 plus 2 times 4. 8. And that's 11. You love it. Okay. This one times this one. This one times this one. Okay. Do we have a result? Okay. Example 1.15. Example 1.15. Should I write it? U. Example 1.15. And U equal to 1, 2 minus 3. 1, 2 minus 3. V equal to minus 3, 5, 2. Then U dot V, what's the result? U dot V. This is the formula. This is the formula, okay? This is the formula, dot product formula. Dot product formula. This is the dot product formula, okay? And so what's the result? Is 1 times minus 3 plus 2 times 5, that is 10. And what's the result? Minus 6. And the result is 1. Okay. And let's do some exercise. Practice this part. Then turn to the question part, which is page 29. Page 29, exercise 1.2. Exercise 1.2. And can you do the question? So in exercise 1 to 6, find u dot v. When you see it's a dot printed on the board, on our board, they don't write, I said before, okay? They don't print the arrow, but they print a dot. When they printed a dot, that means a vector. Okay? Do you see on your board? Is a dot printed. That is a vector. But when we handwriting, in the handwriting, everybody write it with arrow, means a vector. Can you do the question 1, question 3 right now? Question 1, 3, and 5. Question 1, 3, 5 right now on your notebook. Can you start? Start.
Yes.
Okay, the three questions. Okay, if you have difficulties, yeah, just ask. Yes. Good. 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 This is why I asked you to bring good notebooks. Okay. Now, on page 29, on your textbook, page 29, listing these properties, listing these properties. Looks very intuitive. Look, it is recorded. Looks very intuitive. Like I said, vector is just advanced format number. It's just advanced format. So when this time dot product, okay, when you inverse it, you can tell u dot v is the same as v dot u. Yeah. Doesn't matter, okay? You may think this is a trivial. Later, it's getting important. Mathematics always building one and on top another. Each one looks simple, but when many simple stuff building together, they build a complicated building. They build. When you look at each individual, it is a simple. And here, the rule called, this is called a commutative. This, yeah, commutative property. This is distributive. So when you, this dot, you remember plus, you remember how to do this, right? You remember how to do this. And is equal to this dot, this plus this dot, this. Oh, okay. Okay. Are you following?
Yes.
And for the third property, scalar. This this is not a vector. Like for example, like a 2 or 5 or -2, something like that. Okay. This no gossip. Okay. This one is equal to bring this out and do this as a product, dot product, okay? And the rest I will add up. Are you following?
Yeah.
Are you following? Now, I want to come to here, which is the one need to use our angle, need to use our trigonometry. This is the definition. This is the definition of dot product. Okay, it's very it's a kind of boring. No story. No story. It's just this dot this. You do that. You do that. Okay. I want to tell you what's the meaning of the dot product. Remember that dating website? Remember that dating website?
Yeah. Match.
Right, matchmaker. When you dot v dot u whatever, what you are really doing is this one make it we disassemble these vector into two parts. One part is in this direction. Another part is vertical. It's vertical to that direction. It's vertical to that direction. If you no gossiping, okay? If you want to choose this one, if you want to disassemble this one, it's okay. Doesn't matter you which. Here, it's handy for my hand. So I disassemble this one into two vectors. One is the V1, I label it V1. One is the V2. Okay? V is equal V1 plus V2. Right? This one, V1 plus V2, you remember that sum, the adding two vectors. You remember adding two vectors. Okay? This vector and this vector is goes from the original to the final destiny. From your beginning to the final destiny. This is V. Okay. And one thing I need to tell you, this when the two vectors are vertical each other, this is not obvious. Is hiding behind. You cannot tell. If the two vectors, let's say the two vectors, if they are vertical, the dot product is 0. You love it. It's 0. No matter is 2 dimension here, or is 3 dimension. One is over there. Only if the two are vertical. If the two are vertical, this dot this are 0. This dot this are 0. That you just take it, okay? I can show you another formula. So the real meaning u dot v is that so for this vector, you can look at there are two ingredients. One ingredient is same in this direction, in the user direction. Another ingredient is the vertical part. So the meaning of that is actually is this length number, this length times this length. That's the meaning of dot product. A vertical length is called a norm. Is this length times this length. Okay? If this vector, let's say I turning this vector is the same, okay, same length. I'm turning it. Let's say I'm turning over there. Okay? I label it V prime this. Can you tell me V dot U or V prime dot U? Which one is larger? Is this dot, this one larger? First of all, dot is a number, okay? So we can say larger or smaller. This one dot this one, or this one dot this one. Which one is the larger? This one has more ingredient in this direction because you draw a vertical line. Okay. So this one has this much ingredient in this direction and this much. Okay. So this one is the larger. This one is the larger because they are more or less more consistent. If this is a boy and these are two girls, this girl and this is more consistent with this boy. And this girl is less consistent. He wants to go that direction. This girl wants to go that direction. It's in mind. It's thinking is more far apart. Okay. This girl and this is more thinking in mind. More. It's not exactly same direction, but is closer. Is closer to this boy. Okay. So if you want to match maker or whatever, this one will be better suit this boy. Okay. Now if I turn it the other way, if I turn it the other way. Let's say, turn it this way, okay? And let's say this is V double prime. Now you tell me the V double prime dot product U. The three, which one is the smallest? Which one is the smallest? Yeah, this one is the smallest. Let's say this is the third girl. This is thinking more dramatically different from you. Okay? She only has this part, this much part. The length, the three lengths is the same, okay? But for these girls, only tiny part, let's say this is a tiny, okay? Only tiny part is consistent with U. It's the only tiny part with U, okay? Now if it's vertical, then that's 0. That's 0. So another formula for dot product is this. Let me open it. So this, oops, I'm sorry. This is just algebra. You do not need to have any picture in your mind. Like we said, always 2 fingers pointing at the same moon. So this is actually U the length. Okay, U the length, and it's a number, and V the length times the cosine theta, And what's theta? Theta is the angle here, the 2 angle. Okay, this is the 2 fingers pointing at another definition of the dot product. Doesn't matter you are over there. You see, is this length times the dot product. So if you can tell, is this length times the cosine, you got this. When this length times the cosine, you got this. When here, you times the cosine, you got this. When it's here, you times the cosine, you got this. This part. This part is the part that they are in the is the ingredient in user direction. This you find when is a 90 degree. When this is a 90 degree, cosine 90 degree is what? Cosine 90 degree is what?
0.
Huh? Moving 90 degrees, the distance to my foot is what?
0.
It's 0. Okay? Okay? Trigonometry. Okay? Cosine 90 degrees, 0. When it's 0, everything is 0. When it's 0, everything is 0. So this is the say any two of the, if they are vertical, then dot product is 0. Okay. And put in another words, if anything the dot product is 0, they are vertical. So in geometry, in high school, they want you to prove this and this are vertical, and you have to prove. In linear algebra, you can do that. If this and this dot is 0, it's proved they are vertical. Let's say accidentally leave here, the result is not 0. But if I modify this question, if I modify this, okay, these are 2 vectors. What's the dot product? What's the dot product?
4 plus 2, 0.
It's 0. This times this is a 2. This times this is a minus 2. This is 0. This is 0. So adds up is 0. Okay? Are you following? This times this is a 2. Positive 2. This times this is a negative 2. So the cancelled out is 0. This times 0 is 0. This times this is 0. So even though I do not know what's this, 4 dimension, I don't know, the 4 dimension, I cannot imagine 4 dimension, okay? But I know this one and this one are vertical. This one and this one are vertical. It's proved. It's proved that because this is not 0. The length, this one's the length, I will tell you. A little bit gets messed up. This and this one are tangled together. So this one is not 0. This one is not 0. But z dot product is 0. This has to be 90 degree or is 270 degree, whatever. Anyway, they're crossing each other vertically. So they are vertical. This one and this one are vertical. This is much more powerful than you just memorize this dot, this dot, this. When you look at this, you would not think about matchmaker algorithm. This is the algorithm. You would not think about algorithm. This doesn't tell you anything, algorithm. But this will tell you, try to find the larger one. Let's say there's 1,000 girls. 1,000 girls. One boy trying to, and you make a dot product. And you find the largest one. And you say, oh, that girl, maybe is much more suitable, more consistent to your and it's not just the matchmaker, right? There are many others. For example, we want to write a website for a book. There are thousands of books or movies, rental movies, and somebody wants to, and say, what do you want to watch? Say, I want to watch, let's say the first one, let's say the first question, romantic, second one, humorous, funny, I want to watch some funny, humorous. I don't know how to write humorous. Some kind of funny is humorous. Family or action, and suspension. You know, detective stuff, right? Yeah. And you want, so he checked, I want to watch this romantic and action, and you got a product, you got a vector 1 0 0 1, and you can have more, is more dimension, okay? customer and there are 1,000, let's say 1,000 movies. So which one is closer to his preference? You make a dot product. You make a dot product. You find this one. Oh, this one is much more matched to your preference. And I had write. I did. This is a real. I did write a website for selling teas. Maybe you guys, for example, coffee. Maybe you guys. They have many different dimensions. Thick. You want thick coffee? You want aroma. Aroma. And sweetness. Your thickness. You want a thick. You want aroma. You want. Anyway, for the tea, I had 6 dimension. 6. You can say 6 criteria. 6 criteria, and you choose it. Okay. And for thousands of teas on the market, thousands brand teas on the market. For naive customer, I don't know which tea suit me better. I like some tea. But different people has a different taste. Yunnan is a big, making teas. Yunnan makes a lot of teas. I know some of your home countries producing a lot of teas too. Yunnan, like I'm just drinking a new kind of tea right now. It's very famous. I don't know. They are doing a lot of bragging. Oh, this is very good, very very good. Different people have different taste. Even like in the morning, people like to drink what kind of tea. In the afternoon, they like to drink what kind of tea. In the evening, or including me, I'm kind of picky. Yeah, I'm not a tea expert. I know a little bit. I was cooperating with the tea expert. I wrote a website. So for customers to choose, some people do not like too sweet teas. Ladies, they may like it. For guys, for particularly old men, they like bitter. They prefer a bitter taste. They think it's more like tea. 对，苦. Even coffee. Some people like black coffee.
That's very sour. Bitter.
Some like sour. Yeah, sour, bitter. So the different dimension. So is in the space. There's a vector. He likes this kind of stuff. Okay, this kind of let's say. He entered his criteria, and there's 1,000 different kind of teas, and you do a dot product. You find the largest one, and they say this kind of tea is more consistent with your requirement. Okay. This is what I want to emphasize. What I want to emphasize it. Okay, we take a break now. Short break. Okay. So we stop. Is that? And we can prove this one and this one are same, but that's beyond our class. Beyond our class. And we don't want it. The two are the same, indeed, they are the same, the two formulas. It looks very confusing. See, are these result are the same? Yes, they are the same. But I skip proving it. Okay, will drag us away to. We don't need for our purpose. We don't need to get that. This is we are dragged too far away. Okay, and this is more visual. It's more visual. Now, like I said, the norm and the dot product are mingled, are tangled together. So let's say vector dot itself, dot itself. So according to this formula or this one doesn't matter. Doesn't matter. What's the result? What's the result? It dot itself. So it's length. Okay. This means the norm. Norm is the length, vector length. Okay. And times a vector length again itself. Okay, and because it's the same vector, okay, so is what's a degree? What's a degree? What's a degree?
Zero.
Zero, cosine zero. And what is a cosine zero?
1.
Remember? Remember?
Yeah, 1.
Right, it's a 1, okay? The distance from the movie screen to my foot, okay, is a 1. This is a 1.
Maximum.
Okay? Yes. So this brings to our another formula for the norm. So the norm square, okay? This and this is a square, okay?
Square.
Equal to, I just, it dot itself. Okay? It dot itself. Or so is the norm. This is the formula. I will put it in the red box. It's a square root of this one dot itself. So if this is U1, U2, UN, so what's that? What's U dot U? What's U dot U? Here. So it's U1 squared plus U2 squared plus dot 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 plus UN squared. This is the formula. So let's use a simple one. Let's start with the simple one. If this is What is known? Do it on your notebook. What is known? Yes, using this one formula. I can draw on the board. Okay. Where is the vector u and the 3?
5.
Here is the 3. And here is the 4. Okay? 3, 3, 4. Okay? What is known?
7. 5.
What is length? What is length?
7.
Can you do that? Let me. So U1 is a 3. Here we only have 2 dimensions, okay? 3 square plus 4 square. So is 9 plus 16, 25. Is a 5. It's a 5. This is a Pythagorean. 3, 4, 5. Okay. Pythagorean. When we want to calculate a vector's length, like that strange vector a minute ago was on the board, like that one, like I said, I remember is what is this? Is 3 and what's the number? Something like that, a strange number. 3 is a 3. Anyway, the question number 5, that one. To this one, we don't know where to point it.
Yeah.
But we can calculate its length. We can calculate the norm, the vector norm, by using this. By using this. Can you calculate these vectors? Can you calculate this vector's length or the term norm? Can you calculate this vector's norm? Can you do that?
It's 3.
Do it, do it. What's this vector's length?
3.
It's not a 3. It's not a 3. Why you say it's a 3?
Oh, it's not 3. Yeah, right. It's not 3. It may. So, radical 7. Radical 7. Radical 7.
Huh?
Radical 7.
Everybody? So, square root, the first one, we just plug in the formulas. So, it's a big roof. don't forget, okay, square root, big root, big root. Okay, this square is what? Is a 2. This square is what? Also 2. Minus and minus then cancelled becomes a positive. Okay, so it's also positive 2. This one, negative square root, this one times itself. It times itself. The two negatives cancel each other, becomes a positive. It's also 2. And this square is a 0. And this square, 9. And unfortunately, it's not a beautiful number, but is square root 13. Square root 13. Okay. So this vector, I do not know where to point it, but I know the length is square root 13.
Okay.
And here, there's a very important trick, or we call it normalization. Normalization. Normalize a vector. Normalize a vector. Let me take this example. So this is a vector. The length is 5. In mathematics, many times we want just the length, the same direction, but we just want the length equal to unit. We always like unit. There are special uses, like unit circle, okay? We want to find the unit vector, the unit, which the length is 1, okay? How to find the same direction, but unit is 1. Is divided this vector by its norm, then that is 1. So there's a special symbol for that. You already know this is a 5, okay? And by the way, I will also want to remind you, actually, this is another phase of Pythagorean theorem. Another phase of Pythagorean theorem. This is why the Pythagorean is everywhere. Pythagorean is everywhere. This is a 2-dimension. I'm a little bit disappointed that you didn't realize that it is a Pythagorean. 3, 4, that's a 5. Okay. This is just if it's a 3-dimension, then there's a 3-dimension Pythagorean. There's a 3-dimension Pythagorean. When you find the building in this one, it's better. It's better. Okay, for the unit, for normalize this vector, there's a hat. This means the unit is just one, but it's the same direction. Since we know it's a 5, so this is uh, so this vector has the same direction as this, but the unit length is 1. Unit length is 1. You can verify it. You can verify it. This square is what? 9 over 25. And this square is 16 over 25. So adds up. There's a roof. Okay. That's the square. Okay. So this plus this in under the roof is 1. So it's 1. So this is normalized vector. The day after tomorrow is a very special day in Chinese culture. 对，清明 You know,
Yeah.
the people will visit the cemetery. Cemetery. Uh, yeah. 对, I will go with my brother to the cemetery. My parents are buried. Yeah. Yeah, on the mountain. Let's see that mountain.
Mountain, what things to
No.
Actually, we have to go with you.
You cannot even go outside.
Last year I heard that you go to outside with CST department all students.
That was before
Did you take over why last year? You didn't last year?
That was before the virus thing, before the pandemic. Yeah. 29?
From international people. I don't know.